Math for 6th grade. Today we're doing lesson 89. And we're going to be learning about interior angles. If you've ever had your interior decorated, you know that the interior is the inside of your house. In math, the interior are the inside of the shape. We already know about some interior angles. You had learned before that the interior angles of a triangle all add to 180 degrees. We've used that a number of times to help us solve problems. For example, you'd be given two of the angles, and you'd know that if you added all three together, you'd get 180, and you were able to solve problems. Today, we're going to use this to solve a different kind of problem. We're going to try to figure out what the measures would be of all of the angles inside of shapes. Let's start today with a trapezoid. Go ahead and draw a trapezoid on your paper. We already know that we can split a trapezoid into triangles. We use that when we find area. If you draw your trapezoid and you split it into two triangles, now if I wanted to find all of the measures of the interior angles, or at least what they all added up to, I could use what I know about triangles to help me. For this triangle, I know that this angle plus this angle plus that angle equal 180 degrees. Here's another triangle. I know that this angle plus this angle plus this angle also add up to 180 degrees. So while I don't know what each individual angle is, I know that if I took these together, plus this, plus this, plus this, that all four angles would add up to 180 plus 180. In other words, all four angles of my trapezoid would add to 360. Let's use this to help us with a regular hexagon. Do your best on your paper, please, to draw a regular hexagon. If something is regular, that means that all sides are equal. It turns out that if all sides are equal, all angles are equal also. My hexagon is not perfectly drawn, so I hope that yours is better than mine. And here's what we're going to do. We're going to split it into triangles and try to do the same thing we did for our trapezoid. We're going to see if we can add up all of the angles from our triangles to find the interior angles of the hexagon. Starting one corner you like, I think I'm going to stop in the top right, but you can start wherever you like. And then we're going to draw lines to the other corners to make triangles. Would I draw to this corner? No, that would make a triangle. How about this corner? Yeah, that would make a triangle. Let's do that. We're drawing lines to the other points so that we can try to use what we know about interior angles of a triangle to help us solve the interior angles of our hexagon. If I draw to the next corner, oops, I get another triangle. There we go. If I draw to the next corner, I get another triangle. Would I draw to this corner? No, that would just be tracing a line. So now I've broken my regular hexagon into 4 different triangles. And I know that these 3 angles of this triangle add to 180. And these 3 angles of this one add to 180. And these 3 angles of this triangle add to 180. And these 3 angles of this triangle also add to 180. That's all of the angles. Look how they all got colored in when I did that. 1, 2, 3, 4. I have 4 triangles. And each one has angle measures that add to 180 degrees. How many degrees are there in my entire triangle? There are 720 degrees. Okay, now let's take it a step further. If there are 720 degrees in my whole hexagon, and there are 1, 2, 3, 4, 5, 6 angles, and they're all the same because it's regular. My sides are all equal, my angles are all equal. Let's divide. If there are 720 degrees in the divide that into 6 equal angles. Let's find out the measure of each interior angle. 7 divided by 6 is 1. 12 divided by 6 is 2. I get 120 degrees. That means that each of these interior angles is 120 degrees. This is one of our topics for today. We're going to be doing 2 topics today, but this is the first one. You're breaking your shape into triangles, knowing that each triangle is 180 degrees, and then using that information to help you calculate each interior angle. Our other topic for today are exterior angles. Exterior angles are on the outside, and they're kind of fun. If you take your ruler and you take a line that's already there, so here's a side that's already here on my regular hexagon, and if you just keep the line going instead of letting it come down, then you turn, and here we have another side. Put your ruler along the side, and then just keep the line going instead of turning. What I'm creating, put it along the line, and then just continue it, are exterior angles. When I first look at exterior angles, I notice that because they are a straight line, that I can calculate them using my interior angles. For example, if I know what this angle is, we just calculated that it is 120. I could know that this is a straight line, which is 180, minus my 120, would give me my angle. I'm going to show you another way to do it today. If you picture in your brain for a moment that this shape was to scrunch up together, pulling all of these together, and all you were left with are the red angles, notice that the red angles would pull in such a way that each of these angles could fit together to make a circle. Turns out that that works for all shapes. The sum of the exterior angles is equal to 360. And if you look, if we put all those angles together, it would make a complete circle, which is 360 degrees. Since they are 360 all together, and I have 1, 2, 3, 4, 5, 6 of them, and I know that they're all the same because it's a regular shape. I have regular interior angles, so I have regular exterior angles. Let's divide and calculate the exterior angles that way. 360 degrees is all of my exterior angles, divided by 6 exterior angles. Means that each exterior angle is going to be 60 degrees. As you do your work today, please remember what we learned about triangles to help you with your interior angles, and please remember that exterior angles add to 360 degrees to help you with solving your exterior angles.